So this is VCAA 2015 Exam 1. And this is a pretty tricky question, or parts A and B are anyway, because it relies on this strange sort of diagram. Part A asks to find the coordinates of t in terms of theta. So the coordinates there in terms of this angle. First thing I'm going to do is label that with x and y. And once you notice that this y value is basically just the perpendicular height at t, so the y value is just this length here, we can solve this reasonably easily. So we'll just call this y. This radius we're given in the rest of the question. We're given that the radius is equal to 2. So we can put 2 down there. We can also work out what this length is here, because this part here is the x value. Since this x value is 2, this length is x minus 2. If I redraw the triangle just over here, we can say that the opposite over hypotenuse is equal to sine theta. So y equals 2 sine theta. We can say that the adjacent over the hypotenuse is equal to cos theta. So we get x equal 2 cos theta plus 2. And we can just write that in our answer. And I suppose if we wanted to put it in coordinate form, we would write it like this. There we go. Now it says find the gradient of the tangent. This is the next question. Gradient of the tangent to the circle at t in terms of theta. So we want the gradient of this line. But we can do something fairly simple with the line that we've just been given, because the gradient is really y minus y1 divided by x minus x1. We've just worked out that point. So the gradient, not of the line that we're interested in, but the gradient of CT is equal to y minus y1, which is basically just this y value, divided by x minus x1. And this value is x, this value is 2, so it's just x minus 2, which is equal to 2 sine theta over x minus 2, which just gives us 2 cos theta. That's equal to tan theta. Don't get too excited, because we're actually after the gradient of, not CT, but the gradient of the tangent to the circle. We're after this line here, which we could call, say, BT. And since that's a right angle here, the gradient is going to be a negative reciprocal of the gradient of CT.